Let's see if you guys can help me out here a little bit, because part of my system has already crashed on me. It turns out my MacBook and the networking we have here in Malmö, Sweden, really do not like each other. That includes the phone's network, LTE, as well as the Wi-Fi here and the hotel as well. So it's kind of weird. So things completely brown out, but we'll see if we can make this work. You guys want to help me test something real quick? I need you to go to this URL right here, the bit.ly hybrid open1. We're going to try something. We're going to try a grand experiment. This could go really badly. Already, like I said, part of the system's failed. We'll see how much of this stays up. But if you go in there, you'll get this user interface. And you can just put in a little string. You know, I'll just put in 3 here and hit send request. All right. You can kind of see somebody has, of course, being very mature there. But you basically can put in your string of text. So you notice what's happening. It's coming back to you from Google. So I'm just trying something real quick to see exactly what people put up here, right? Because we can kind of see, yeah, I know who you are, by the way. So I can trace these messages back to you. Because here's kind of the idea of this little demonstration. I have all this, as I mentioned yesterday, running into 3 clouds. I have the concept of Google, Amazon, Azure, as well as my private cloud running here on this laptop. The private cloud is acting up a little bit. But all it's really doing is taking the messages you guys are pumping in here and simply responding back to you with the cloud that message is coming back from. So in other words, you're putting your message in, and it's getting a response from a particular cloud. You can kind of see it's GCP there. That's the Google cloud. And you kind of see the activity here is all on Google, and we're running about 1 to 3 transactions per second. Not a lot of traffic there. But let me try this real quick. Let's go over here. And let's actually turn the Google worker offline. So I'm going to take this one down, and let's see what happens next. Okay, so the Google worker is no longer online. And you can kind of see what happens next. Everybody is now on the Burr cloud, which is my local cloud. So what's happening here, if I can show you this, let's do that. Basically, as you guys are interacting with this user interface on the right-hand side with your phone, that's up at the Google Cloud, right? So that user interface is at the Google Cloud. It basically means we're trying to process local transactions within that same cloud. But at any given moment where we run out of resources in that cloud, it spills out to the next cloud, to the next cloud, to the next cloud. So now your transactions are actually coming into Burr as opposed to Google, right? So basically, it's a hub and spoke like architecture, like you see here. It can be set up in a full mesh if you want to as well, like where everybody's doubly linked to each other in like a star topology or something. But in this case, you can kind of see that the Google transactions are now showing up here for Burr. And then if I want to come back and put Google back online, bring it back up again, okay, you'll see that most of the transactions start flowing the other way. In other words, it'll go back to going to Google. Let's see here. One more, and send request. There it is. Now we're back on Google. Okay? So this is a simple concept, right? The thing that I'm so excited about when it comes to all this Kubernetes technology is that I can build applications that run in any cloud. That's really the whole point of what we've been trying to do for the last several years with Kubernetes within the Kubernetes ecosystem. Yes, you can always build an application that runs only on Amazon. You can easily build an application that runs only on Azure, and you can easily build an application that runs only on Google. But in this case, we run a single application across all of the above. And you can kind of see what's going on here. There's my different dashboards here. Here's my Amazon. And of course, this is what Amazon looks like to me as a developer. That's another big win, is it's the same user experience for a developer across Amazon or Azure. And here's the user experience for Azure. And actually, I can just bring up the same screen so they all look the same. Okay. See, my network's a little slow here. But there's Azure. And here's the Google combination here as well. And what we're doing is we're simply running the exact same application. In this case, it's the AMQP interconnect router. So this is the Apache Qubit dispatch router. This person's job is basically to route AMQP traffic wherever you want it to go, across the globe, if that's what you want. Because here's one thing that's kind of cool about what you guys are doing here with these little messages you're pumping in. When I said take it back to Burr, let me come over here and drop this worker again, so it comes back to Burr. You're going from your phone, okay? Hello. You're going from your phone. There's my hello, okay? To California, where the Google server is running, back to this laptop here on stage. So that's kind of cool. And you can basically set up these cloud servers wherever you want. I just happen to set 3 of them up in California, but I could have put some in Europe and some in Asia. And it also is fairly clever. It looks for lower latency transactions, too. So it's trying to measure latency as to where it's routing your transaction in this case. So in this case, Burr is the central hub of this particular architecture. OK? And if I actually increase the load here, let me bring this one back online. I have a load generator here, so let's bring the load generator online. You'll see that when it comes up, it'll actually generate a ton of messages. Now, the reason I'm telling you about this is, one, we want to see applications that run across any cloud. That's really one of the key critical points of Kubernetes in general. And that includes microservice-style applications, traditional monolithic applications, microservice-style applications, and this new serverless or function-as-a-service-style application. And you can kind of see here's my load being generated. And again, local load stays local, right? So you can see that Google is running about 2,000 transactions per second. And a few of them are spilling over to Burr, right? About 12 transactions per second. But if I kill the Google worker, watch what happens. OK, it'll all come to Burr. And it looks like a little bit over to Amazon. So some of the transactions are spilling out to Amazon now. And if you can watch the flow of things here, too, right? So it's going from Google to Burr, and then a little bit over to Amazon. And then and you can kind of see that if I put more messages in, more, right? There it is, right? It's coming over to Burr. And then if I kill Burr, you'll see it spill all the way to Amazon, and, of course, spill out to Azure. But the problem is my user interface for Burr is acting up right now. I can't even log into it. It is not behaving correctly. So this is the local one that the user interface on it has died, and that means the API server has died. I can't even connect to that server anymore. Basically, it's running right here. OK? So this one I called Faz. Yeah, it's not letting me in. OK. So hopefully that was a little fun. Was that kind of cool? Kind of get you guys warmed up? All right, let's dive into this topic. What I'm going to have to do now, let me see if it'll even let me stop it. I'm trying to see if it'll even let me shut down this local one. And what I want to do is start up another one, and hopefully it'll come up and be OK while we switch gears here. So basically, I'm switching virtual machines on my local machine and starting a different cloud cluster on my local machine. So I'm basically shutting down this one I called Faz, and actually you saw VirtualBox just died. All right. We'll restart it. So that one right here just died. So we brought it down. But I'm going to bring up this other one. Let's see if this works. OK. Start VM KNative. We'll see if we can bring up this other one. And we're going to let that run as we dive into the presentation. But basically, this is what we were just looking at. 4 different clouds, AMQP technology to basically route your transactions around all the clouds. Again, it's got latency, sensitivity, and intelligence. You also can identify the cost. That's one reason it would do. Basically, the cost is set up so that it goes local first, and then Google is actually my next highest priority cloud, and then Amazon my next highest priority cloud, and Azure the next highest priority cloud. And it basically routes those transactions wherever you want to go. The coolest thing about that is you then can take advantage of CPU that's available wherever it might be on the planet, and the cheapest price of that CPU, okay? Or memory in this case. So that's kind of the thing that's fun about it. So hopefully that kind of sets you up for what we're about to talk about here. This is even more advanced than the Istio stuff, which didn't want to work for me too well yesterday. So KNative is actually based on Istio. And the system that just broke on me is actually OpenWhisk. So we won't see the OpenWhisk piece, but we'll talk about it briefly. Let's see if KNative comes online. All right. We got to fly here. We got limited time. So, OK. There's more of these upcoming presentations. Just be aware of that. And come on, machine. Let's go. All right. That's not going to work. There we go. More of my Bruce Lee stuff. This is The Way of the Dragon. If you've not seen this one, I highly recommend it. Bruce Lee kicks Chuck Norris' ass. No one beats Chuck Norris but Bruce Lee. Just keep that in mind. It's a really funny scene. You can catch it on YouTube. Okay. We're going to run another raffle. So if you guys are familiar with what I did yesterday, I have another Chromebook. So again, pound Øredev for the hashtag. Mention at Burr Sutter. Take a photo of the session, and you should get in the list of what we'll pick from there. So here's a key question that you have to ask yourself. This is often a question I ask when I talk to senior executives, when I go out and meet with big banks or big insurance or big airlines or big transportation or whatever. I ask the executive, what is the key strategic advantage for your organization? Or do you think software, apps, and APIs, customized software is a key strategic advantage? And sometimes they go, yeah. And it's kind of about that level of, passion about the subject. Or I say, is IT actually a cost center that you have to better streamline? And often the executive is like, yes, those people are expensive. I need to find a way to streamline those expenses. That's my job. That's how my bonus is set if I'm an executive at a big company. And I've thought about that for a great length. And it's a key question we have to ask ourselves as digital creators, software developers, and people who actually produce the stuff that people want. We want to work for the former and not the latter. Does that make sense? We want to be valued because of our ability to create something from nothing that very few people on this planet actually have. If you think about the 7 billion people on this planet, there's approximately 10 million professional software developers supporting that 7 billion people. And of the people who come to conferences and meetups and show up for a continuing education, even just looking at YouTube or Lynda or some other kind of asset, you represent one of 100,000 people on the planet or something like that in this room. Right? We're a tiny fraction of a group of people that are trying to make the magic happen for these large organizations or for our own startup or for other ISVs. So we want to be part of the former, so just keep that in mind. And I love this quote from Mr. Einstein here. We can't solve the problems with the same thing we used to create them. And so you're probably always wondering, when you look at this new stuff that we're going to show you right now, like in the case of serverless, isn't this something I already did already? And the answer is yes. We repeat ourselves every couple years. That's what we do in this industry. Okay? So the microservices thing, you guys are looking at that going, isn't that like SOA? Sure. Right? And someone's going to look at this and go, isn't this like CGI from the mid-90s? Sure. Right? We tend to repeat patterns because the funny thing about software, enterprise software in particular, is the things that enterprises need have not changed over the last 50 years. They stay the same. Okay? Those things stay the same. There's some nuances in how we deliver the thing, but otherwise what the people need from their computers has always been about the same kind of thing, right? They need transactions that work, and when you persist, the data's still there when you come back tomorrow, right? The majority of what we build are user interfaces that simply slam data into some form of API or backend, write it to some database or another, typically a relational database, and then get the data back out and put it back in a user interface or API. That's most of what we do and have been doing for really 50 years now. So those things haven't changed, okay? This thing's not working for me. We showed you this on Tuesday, right? The concept of understanding your application is very important. Understanding what the modules and the components of the application are inside it, thinking in terms of your microservices, understanding how we network those services, that each have their own database. They have a bunch of entry points and different APIs. Understanding this as our application now, as a new application framework, is super critical. But actually, this is a great quote from Mr. Spock here. Change is the essential process of all existence. So already, what I showed you yesterday is already old. Okay? So we no longer want just microservices. We also want functions as part of our application infrastructure. So that's where the serverless idea is really starting to come into play. So serverless has a lot of different definitions depending on who you ask. You can kind of see here's one from the Cloud Native Computing Foundation, the CNCF, the originators of Kubernetes, the people who built Kubernetes overall. Okay? You can kind of see that they're very much focused on not requiring a server with a fine-grained deployment model where you can kind of basically consume resources only when you need them. Only when an event has woken up your application logic should your logic run. Now, this is a fundamentally different way of thinking. Over the last 20 years or so, you guys have built WebSphere apps and WebLogic apps and Node.js apps or Python apps. It doesn't really matter. And your purpose was to keep that app running, right? We take great pride in the fact that our JVM can stay up for a week at a time and doesn't go down. We take great pride in the fact that our JVM can stay up for a month at a time, maybe even 6 months at a time before it goes down and has to get restarted. In this new world, we don't want that anymore. The new serverless world is we might restart every 2 seconds, or every day, or every hour. In other words, the interval's gotten very low. Because we don't want to use that memory and CPU unless there's some need for that, some load that's being placed upon the system. And you can see there's a difference between serverless and FaaS, function as a service. Okay? So the serverless world basically is thinking about these ephemeral concepts of just simply leveraging backend as a service capability, right? And just having some form of some form of management technique where you're not managing servers. The goal is so that developers can not think about computers if at all possible. They just write their code and throw their code at the infrastructure, and the infrastructure basically runs that code like magic, right? And that's really where we want to go as software developers, focusing on our business logic. And so in the new function as a service world, though, right, we have a specific engine a specific function as a service engine that's going to execute our code in a certain way. There are some weird oddities about that, though. Every function as a service engine has its own unique API. You write unique code per engine. You write it uniquely for Amazon, you write it uniquely for Google, you write it uniquely for Azure, and you write it uniquely for all the ones in the open source ecosystem, too. So that's one thing that's bad about function as a service right now, is the code bases don't port. And if you're a Java person, you're used to basically having the ability to move your code from one to the other, right? We could move our code from WebSphere to WebLogic to JBoss to Tomcat to something else. We could do those things. In the function as a service world, it's not quite as clean as that. But we've been working on this concept now for a little while. You can kind of see that, much like the short history of microservices, we've been thinking about serverless for quite some time, too. And as a matter of fact, the serverless term came out back in 2012. You can kind of see where it was coined by the Iron.io folks. So early implementations of this concept came from Firebase and Iron.io. So Firebase was like a real-time database in the cloud. If you're familiar with it, it was reacquired by the Google team. It's ex-Googlers who got acquired back by Google. Iron.io was also a message broker in the cloud, and you could use your messaging queues up in the cloud from just a RESTful API. Very cool stuff. The Iron.io team kind of came up with this concept of serverless. Amazon Lambda was born in 2014, and then the world kind of exploded since that point, right? We now have, everybody's got a serverless framework of some sort or another, okay? And you can see that actually the Iron.io team is now part of the Oracle team, Oracle FN project. So these folks, these engineers, just move from one team to another team in some cases and join new projects, okay? Now here's the key thing to understand about your serverless architecture as you think about it. You have to first decide, are you going to consume a service versus build a service? Now, I know many of you folks here are awesome Java developers, right? What do Java developers love doing? Reinventing wheels. Yeah. So how many people built their own MVC framework? Oh, not too many here. Often, if I'm in the US, half the hands go up. They built their own MVC framework because, you know, no one needs Struts or Spring MVC or the 45 other ones that are out there in open source. I can build my own and make it better, okay? Haven't anyone else build their own message broker? There's always a few message broker developers in the room. Fantastic. See, forget about the 10 that are out there that are awesome in open source. I can build my own and make it more awesome. So this concept is actually kind of a challenge for us in the Java community. We love reinventing wheels. And in this new model, this new mindset of serverless, you should not reinvent wheels. You should leverage wheels that exist. So, because it's serverless because of backend as a service and software as a service. Find a service that you can consume and use, and don't try to reinvent that thing. Okay? So it's all about these services. Maybe you have HTTP as a service. So we now think of this as the HTTP gateway now, or basically as an API gateway. It's the HTTP input and output of our system. Get, put, post, and delete comes through this channel now. I don't have to write that code. I can just basically leverage that endpoint or that solution. So it might be Nginx, it might be HA proxy. There's a lot of solutions in space. And of course, Amazon and people like that provide this as a service. Okay? You might also have something like SSO as a service. And there's a lot of different SSO providers out there now. So I can have some form of OAuth token provider. I don't actually have to write that in my own application logic anymore. I can just simply use one that comes off the public internet and is hosted as a service. Okay, I might have storage as a service. This is the concept of a CDN or some form of asset or storage facility where I can drop my PDFs, my images, my videos, something of that nature. Okay? Maybe I have a cache as a service and a database as a service. I don't have to write my own database manager anymore. I know as a Java person you'd like to, because, you know, we can. And actually, I did write my own little database manager back in the late 80s for fun, just because, you know, as a student project, you do that sort of thing. But now we want to consume a database as a service. We don't even want to manage a database any longer, let alone create one. Okay, but messaging as a service. I don't want to build my own message broker. I want to leverage one as a service. And specifically, if it uses the JMS API as a Java developer, or maybe I have AMQP protocol that I can speak to it as an interoperable message protocol. Notifications as a service for like push notifications to a mobile device, or text messages, or emails. And then I build my custom application components. So you kind of see that you look for the service you can consume, then build your custom microservice, your big old application that consumes and interacts with those services. So I might have a microservice that does interact with the message broker and the actual database as an example, because that's where the meat of my business logic is. But then it gets interesting because you start introducing the event-driven aspects of the overall service, the overall application, and that's your functions, function as a service. And you can kind of basically have event-driven input and event-driven output. And the whole goal of that is to have the synergistic relationship that produces that API, that gives you that user interface, that gives you that mobile application or IoT input. It doesn't really matter what's on the left side there, right? I can then have this whole thing where my user's using a mobile device, uploading a video or a PDF, dropping in the storage. They've gone through SSO, right? They now are interacting with my RESTful endpoints through HTTP. I'm accessing the database. I'm getting data out of the database and sending it back to them. All that's part of the new serverless architecture. So I'm not saying that this will work for you well today, but this is the mindset that we're going to be getting into over the next several years. Where can I use a service? Where do I have to build my own big honking service? And where can I just use a little bit of code to glue some things together in unique ways? The nice thing about this little bit of glue code here is you can reglue it different ways. If you want to change the workflow of your application, you just re-snap these things together. You're also going to see a lot of people in the BPM space. Like we have an open source project called JBPM as an example, which is an ultra lightweight way to re-workflow your application. So you can basically decide, OK, the flow of events through the system are going to change based on the fact that our business rules have changed in our company. All right. Now, here's some key things to understand about microservices versus function as a service. So in a traditional microservices programming model, you write the code just as you always have. You write the same code you wrote 10 years ago. You write the same way today. Okay? Your JAX-RS with JPA, that's fine. If you want to run a servlet, that's fine. If you want to run anything that you did in Python or Perl or PHP or Ruby, it's the same kind of code as it was before. No difference in our microservices code than it was in our traditional monolithic code, really. It's a long-running process with a known programming model. In other words, we want that service to stay up for weeks at a time, if not months at a time. But in a serverless world, start thinking in terms of, it's not my control, it's the cloud control. The cloud determines when it runs. I'm not waking up a process, listening on a socket with a multi-threaded backend that's waiting for packets to flow down a TCP/IP port in the serverless world. You can, okay, but that's not the mindset you want to be in, like you would be in the microservices world. So, and the weird part about this is these worlds are being blended even right now. Now, it is a new programming model. If you truly do like Amazon Lambda, different programming model, a different way to write your code. And the problem with that I have with that is that it's not fully portable, right? You can make it portable if you work hard enough with different frameworks that are available to you, like the serverless framework and some others. But by default, you're bound to that platform forevermore. Another thing to think about, too, is this is not a mature environment over here. We haven't figured out all the debugging techniques, all the tracing and monitoring techniques like you have in a traditional microservice architecture. Okay? So there's some goods and bads, right? The good news is you got some automatic scalability, you got some focus on cost reduction, you only are paying for resources that you're using right then, like CPU and memory as an example. You have better capacity utilization. You can also write the code faster because it's smaller. That's kind of cool. But debugging, deploying, some of that architectural complexity is a problem. There is a vendor learning curve, a learning curve and a vendor lock-in. Now, here are the FAS players in open source and the Kubernetes ecosystem. You can see there's a bunch of them, and these are the most notable ones. You can see Kubeless is pretty popular. Apache OpenWhisk comes from IBM. Riff comes from the Pivotal team. If you're familiar with Spring, right, the Pivotal team has Project Riff. That's Mark Fisher's project. FN project comes from the guys who are Iron.io that are now part of the Oracle team. That's Chad Almera's project as an example. And you kind of see, based on a recent survey, that Kubeless is the most popular of the batch. OpenWhisk is the second most popular. And you kind of see, though, that for people who use a hosted function as a service, Lambda is by far and away the most popular, and from that perspective. OK? Am I moving too fast, by the way? You can say, Burr, you talk too fast. That's OK. I'm kind of curious to see how this thing is still not quite up here. Look at that. Internal error. Making we might not be able to get the cluster up. There's something about this network that makes my VMs fail. I have to figure this out. Let's see here. Well, let's just go up here. Yeah, it says it's trying to run. I'm trying to bring it up. We'll come back to that in a second. All right, well, let's let it cook along there a little bit longer, see if it comes up. Oh, and one thing I should mention. You guys live here in Malmö, right, Sweden? I didn't realize this. You guys are like Southerners. I was looking at this earlier because the gentleman and I were looking at the map earlier, my AV guy over here. And I was like, oh, wow, you guys are Southerners because, you're the southern part of Sweden. I'm a Southerner, too. I'm actually grew up in Alabama. Even though I'm a real fast-talking person, I grew up in Alabama, see, deep south here in the United States. So we're like all Southerners together. And you guys even say, hey. Now, in the case of Alabama, we say, hey, y'all. You guys just say, hey, but you could add the y'all to it really easily. And what's really funnier is I'm even further south than that. I'm actually originally from Hawaii, so I'm wearing my T-shirt from the North Shore here from Hawaii, but it's even further south. You can see it's out in the middle of nowhere and very far south. So I dig the southern thing. So you can kind of see, yeah, you guys are still, not that south, I guess. And it is kind of cold here, too. All right, is my VM going to come up? OK, it tried. Let's see, will it let me log in? Let's see here. It might work. We'll find out. It is really not too happy, though. Dun, 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 dun. OK, let me log in. That's a good sign. All right, then. The IP address is not reporting back correctly. Let's try this. We'll come back to this in a second. So I'm trying to bring up a whole new virtual machine. OK, it's 104. Will it bring up the dashboard? All right, we'll come back. It might pop in here in a second if it figures out how to bring it up. But if you think about the platform that we build our applications on, if you think about, OK, good. If you think about the application we build our platform we build our applications on, you kind of think of it in terms of, I've got a series of computers and infrastructure that I have. I have these racks with 1U rack-mounted servers in my data center, right? It's got nice network cabling and things like that on it. And so if you were old school, you actually built the whole stack yourself. And I've done that before, right? I've done the racking and stacking, the power and the pinging. And in some cases, it was actually with mid-tower machines that I had to lay out beside each other because we didn't have a cool rack with 1U rack-mounted servers back then, right? We had mid-tower machines we built ourselves. And we built our own little, data center from that perspective. So you could do it all yourself. But as you notice, as you move through this series of stacks here, what we're trying to do within this overall world is remove complexity from you as a software engineer, you as a software developer. So in the case of infrastructure as a service, I want to go to a cloud provider, or even if it's a private cloud provider, and let someone else figure out the hardware side of it. I don't have to worry about power and ping. I don't have to worry about racking and stacking. Someone else drags cable. Someone else deals with the air conditioner if the air conditioner goes out. Someone else deals with the fact that we air condition so much that we need water-cooled computers, right? And we have to deal with water being pulled up someplace inside our data center. I've seen things like that, too. We actually talked about building a kiddie pool at one point, so the water had a place to go. So you want to deal with the infrastructure, or not deal with the infrastructure, and then you just keep moving up this food chain here, right? So in container as a service, where I'm dealing with a Kubernetes backend, I don't have to worry about the operating system as much anymore, right? I don't think about the virtualization of the operating system as much anymore. I'm just dealing with my container, and of course, it still lives in an operating system, and my Java application or Node.js application thinks it's living in its own computer, but it's still just this little bit of container execution environment, right? So it's a container execution environment like Kubernetes, but it basically runs it at scale. We'll show you some of that if my server will work correctly for me. But you can kind of see we still think about our data and our business logic and the actual application. In the case of platform as a service, it's very similar to container as a service. These worlds are very similar. The big distinction is instead of dealing with a container, I just deal with my app. Here's my WAR file versus here's my container image. That's really the primary distinction between those two worlds as I see it. So you can actually have both in one system. Like in the case of OpenShift, we have both capabilities. You can basically say, here's my WAR file, or here's my GitHub repo, or here's my container image, depending on which one you want. And then, of course, the backend as a service, the goal there is to basically ignore even the containers aspect of it. Just use that message broker, just use that SSO, just use that database. And then the function as a service, the ultimate goal is just to get down to the skinniest bit of business logic. Okay? So you can kind of decide where you want to live along the spectrum, and pieces of your application infrastructure will live at different levels. So not too many people are using function as a service at this point, at least not in a private data center setting, but more and more people will. In the case of OpenWhisk, which is the system that I just killed, so it's not running anymore, but it basically allows you to do a function as a service solution that basically has JavaScript, Swift, Java, Python, just different language runtimes. And actually, let me show you the code real quick, just so you see it. Even though I just killed that environment. Let's see if I have one here. So here's hello world for Python, okay? Here's like hello world for JavaScript. It is just a function. Even in the case of Java, public class with a static method, JSON in, JSON out, it is nothing more than a function in the case of OpenWhisk and other function as a service providers. So this function definition, of course, is going to be dependent upon your function as a service provider, your function as a service engine, all right, your FAS engine. And the cool thing about it is you just simply deploy that. So here I would basically say update the hello world function to hello world JS, or update the hello world function to hello world Py for Python. And I can replace the implementation out from underneath the system in a pretty straightforward way. Like I said, don't have that running anymore because it was the one that was acting up. But what we have now, if things are OK, let's go look at it real quick. All right, my Istio is up now. That should be OK. And my KNative is up. So we're going to interact with this guy called KNative here in a second. But with OpenWhisk, you do have a basic programming model that looks like this. Whisk action update, whisk action invoke, and a few other commands like that. There's also whisk action list, right, to get a list of all the different actions that are out there. And you can see the programming model is very straightforward. And actually, let's show you another bit of code here if I can find it. Let's look at this one. OK. So one that's a little bit more complicated, actually. And just a couple other like this one. So like here's one with parameters. You can kind of see there's the Python parameters, JavaScript parameters. Go away. And then, of course, Java with parameters. And here's, of course, our Java project. Notice it is a standard Maven project in the case of Java, right? You know, you can use a Maven-based fat jar, generate a fat jar in this case to actually deploy into the runtime environment. But you can kind of see just basically JSON in, JSON out. And you write a function. And that's all you have to do in this function as a service world. So that's kind of the cool part about function as a service. And that's really what OpenWhisk is giving us. So we'll come back here real quick. And don't have a lot of time left. But we'll keep going here. All right? So OpenWhisk has this concept of an action, a package, a feed, a trigger, a rule, an activation. So the action is, in fact, your function programming logic. I actually think of it as like a struts action. You remember the struts action way back in the day? So it's kind of like you could hang a struts action off a certain HTTP verb, right, and a certain URL. You could basically say, oh, if the user hits a get on this sub-URL, this sub-URI, right, respond with this action. It's kind of the same idea. So the action basically is invoked dynamically based on the user input, based on the event that comes into the system. By default, all OpenWhisk actions respond to HTTP out of the box. That's nice. And they also have their own command line tool for invocation. But what you can do is you can create this concept of a feed. So the feeds would come from different providers within the OpenWhisk ecosystem. There might be an AMQP feed. There might be a FTP feed, right? Think of different kinds of protocols that you want to basically grab the events for. Maybe SMTP, maybe MQTT, right? It doesn't really matter what the protocol is. I want a feed or an event source for those different protocols, and that would be the triggering mechanism for my little action application or my little action function. Okay, and so basically the feed is defined. You identify a trigger, okay, and the rule, of course, associates the trigger and the feed all together and ties that to a specific action or sequence of actions within the OpenWhisk architecture. We actually ran this at great scale back a few months ago. We actually ran an application with over 1,000+ users. We're all sending images into our system. And we used a function, in this case, OpenWhisk function, to execute a TensorFlow-based application that did inferencing when it came to an image that was uploaded. So you uploaded an image, and it basically ran the TensorFlow AI system that basically said, OK, that's a horse, that's a teddy bear, that's a ladder, it's a phone, it's a laptop. And we did the bounding box and actually scored things accordingly. So you can actually do a lot with these actions, these functions. You can put pretty much anything you want to in them. You just have to give it enough resource to execute. In the case of a TensorFlow-based function that we had, we discovered that if you give it less than a core on the CPU side, it wasn't going to run anytime soon. You actually need to give it 3 cores. Okay, so basically every event that came into our system took 3 CPUs to execute if you wanted to get the time interval short enough so that it could respond with the, yes, that's a horse. And here's the bounding box around that horse, as an example. So the good news is about an OpenWhisk architecture or any kind of function as a service architecture that sits on Kubernetes is you can tune those parameters yourself. You can basically say how much memory does this component get, how much CPU does this component get, how many of them are pre-warmed and living and ready to run, and how many maybe are in dormant state that will run based on the event stream that comes in. Okay? Here's what I showed you earlier. This is kind of what the code looks like in the case of JavaScript. And you guys, by the way, have access to these slides, to the bit.ly serverless cube down here. So make sure you have access to the slides. There's a Maven archetype we've worked on for OpenWhisk. And of course, there's a detailed deep dive in the bit.ly fast tutorial where you can go try some of this on your own, as well as an online learning experience. Here's the Java version. Of course, Java's a little bit more verbose. You also have a slightly different update thing here where you basically say what my jar file is. And in the case of Node.js or Python or Ruby or whatever else, you would just use a zip file if you have multiple files. So it doesn't have to be a single file. You can have 25 files in your application function, right? You just have to zip them up in the case of like a JavaScript application. Okay? Let's talk briefly about KNative. And actually, let me see if my KNative is going to behave correctly. Let's see what it looks like here. Not that one. So that's the OpenWhisk one that I had to kill. So let's go back over here. Kubectl. Get namespaces. So everything in Kubernetes lands in a namespace. Your systems administration team will decide what those namespaces are for you. We also refer to them as projects. KNative tutorial. Oh, it helps if I spell tutorial correctly. There we go. Kubectl get pods. OK, no pods running right now. Kubectl get all. But I have a few other resources that are here. OK? So now we're going to switch gears a little bit from function as a service into another form of serverless in the Kubernetes ecosystem. And this is insanely new stuff, meaning it is bleeding edge, this thing called KNative. It's actually a very powerful concept. It came from the Google team. They basically have it as part of the Google Cloud function. So it's part of their function as a service engine within Google Cloud itself, but they've open sourced it. And it sits right there on top of your Kubernetes environment, right? You can install it on any Kubernetes, assuming you have cluster admin. So, and it's based on Istio. So it actually layers on top of Istio and adds some new capabilities on top. For instance, notice that I have these additional CRDs here. Get CRDs. Right? These are your custom resource definitions. You can see I got a bunch of them for Istio, because like I said, Istio is part of this. But also I have like grep. Let's go with eventing. No, let's just go with serving. Serving is the most mature one at this point. But you can see there's a concept of a service, a route, a revision, and a configuration. These are new object types that are now part of your software development world. Okay? Everything in Kubernetes is basically nothing more than what they call a kind or an object type. It's a chunk of YAML. You can even kind of look at the YAMLs. Let's see, get deployments. Right? Here, so let me look at this guy here. kubectl describe. Actually, let's do this. Get the deployment. That one, YAML. Right? So I can kind of look at the YAML if I want to. And this is a good example of an object type within the Kubernetes ecosystem. This is one I did not produce, by the way. This one was generated for me automatically. But if I come up here and look at the kind deployment, okay? So there's different object types that are all throughout the Kubernetes ecosystem. Every Kubernetes environment you'll get access to will be slightly different because the systems administrator can customize it any way they want. You as a software engineering team, software development team can customize it as you want. And in this case, we have all these kind of cool get CRDs, grep Istio, a bunch of them here like Istio and KNative. But let me see if I can make this thing work. Okay? Could I get pods? All right. If that works for me, let's see if this will work. Okay? So what I'm going to basically do now is I'm invoking a certain component of the application. So basically, we're calling this little thing called greeter. It's just a little hello world as well. Here, I'll bring up the code while that thing is thinking about it. What's happening is it's trying to get my IP address, which is taking forever. But notice what happened there, too. As it's calling it, notice the pod came to life. Okay? So that's really the magic of what we're dealing with now. So by default, a pod is a living, breathing thing. It's a computer from your code standpoint, right? That's the way to think of it. The pod is your app running, but it's using CPU and it's using memory. And then what KNative does, over and above what regular Kubernetes does, is it scales to 0. And it scales up from 0. Okay, that's really the magic trick that it pulls off. By default, if you think of it from a regular Kubernetes perspective, it always tries to give you one. Okay, you're always living in the one pod world. But here's a little bit of code here. You can see it says Java, KNative, Kubernetes on OpenShift. You can see there it is. Okay, and watch what happens as we hit about 60 seconds or so. You'll see that KNative will go, OK, no one's using that component anymore. Let's tear it back down. So if you do have applications that are kind of intermittent, meaning they're only used at 9 o'clock in the morning when everyone signs into work, okay? They're only used on Black Friday like we're about to experience for retail. That's the only time we're going to use that component. They're only used when we have lunch and everyone's playing games in the home office network, whatever it might be. You can think of any kind of cron-like job as maybe benefiting from this kind of technology. If it runs at a certain time window and it's kind of bursty, then maybe I might use this as an example. And you should be able to see, as we get beyond 1 minute, that it will start to scale down. And we'll just keep watching that right there. But let's look at the code here. Let's just actually change this up a little bit. Let's see if we can actually make a code change to it. Dev here. All right, I'm going to save that code, come back over there. So it's terminating now. You can see it's going down. Even clean compile package. We're going to build a fat jar out of it. And here's one thing that's kind of cool about KNative. This works not only at the function level like you see OpenWhisk, it works off anything that goes in a pod. You can put a COBOL application in this if you wanted to. You can have a C++ application. You can have a Python application. You can have a C# application. It doesn't really matter. In this case, I have a Java application. Let's see if I can go here. And so now that pod is gone. But let's do this, docker build -t, dev local greeter. OK. I'm just overlaying the existing image. This is not actually a nice thing to do, but let's just do it real quick. All right, so my Docker file. Where's my Docker file? Where's my Docker file? Oh. This is actually using a different build routine. I forgot about that. This is actually one of the things we've been experimenting with. It does have a different build routine, and I made note of it here. It's called jib, so I don't have to use Docker to do my build. Okay, I can use this Maven plugin to use my build. There's a lot of different things happening in the image build category within the ecosystem. So Builda, Podman, jib, Fabricate. There's a dozen of them that have exploded in the world. So you don't have to type Docker build any longer. It's kind of the ultimate goal. Okay? Let's see if I can basically call that endpoint again. And again, notice there's no pods running here. And it should come to life. Okay? And while that's cooking along, let's actually go look at the user interface over here. Dun, dun, dun. And where is my tutorial? Okay, right here. Okay, so there it is. It's coming to life. See, there it is. It's now ready. So running. OK, it's still trying to invoke it. So it's literally waking it up from sleep, getting it to start up. And then, of course, it should come back with our response, hopefully with the right version of the string that we just modified. But you can kind of see it does take a little time. So KNative, again, is brand spanking new stuff. It is certainly nowhere near production ready. But it's an interesting concept where I can basically apply a little bit of load and have pods kind of spring up based on what I need, right? Based on my need there. So there's the Øredev, OK? And see it's still running. Now here's what's cool. Once it's running, let's fix this real quick, because one of the reasons this is taking so long is because this minishift IP, OK? The minishift IP is really messed up on this network. It does not want to work correctly for me. So let's fix it real quick. It is, this is what version number? It is the 104. We'll just hack it real quick. Dun, 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 dun. We're just going to hard code it, so we don't have to look it up. 192.168.99.104. OK. Yeah, 168.104. All right. Let's call it there. OK, see, that looks up much faster. So there it is. I'm out interacting with it. And here's what's kind of cool. When the system is up, when the pod is up, oh, I got to fix this one too. Let me fix this one. Where's my little polar? Again, we don't want this IP address. We don't want it to look up the IP address. We want it to basically just use 192.168.99.104. OK, looks like it's still running if I hit it quickly enough. OK, so you can kind of see that once it's running, I can interact with it with a lot of load. It just takes a while to get it to wake up. And then once I stop running against it, and all events are basically no longer a part of the system, it will wait about 60 seconds, and it'll trim that back. OK? Now, if I hit it with a lot of load, I have another script here for a lot of load. Let's see here what this one looks like. This one basically runs 30 concurrent. Let me change it as well. 192.168.99.104. And I know we're out of time, aren't we? OK, but let's see here. Let's see that real quick. And notice basically what happened there. I hit it with enough load that it actually spawned 3 pods to respond to that load. And so now I have 3 pods up and running. And by default, I do get round-robin load balancing. As you can kind of see right here, that's the standard Kubernetes behavior, because you get round-robin load balancing for across the pods that meet the label within the label selector. So you can kind of see it's hitting the different computers there. That's why the numbers are different. It's just a JVM with an increment, a little incremented counter. But I can keep scrolling across them. But even with this amount of load that I have running right here, it'll notice that that's not enough load to justify 3 whole application servers running. OK? Because that's basically what those things are. They're little Spring Boot apps in this case running Tomcat. But Tomcat, by default, has 100 threads in its thread pool. It's a real app server, if you will. Right? It can handle 100 concurrent requests in any given moment. But I don't actually need all that capacity based on the little bit of load that I have running here in this little bit of Polar. And if we wait long enough, you'll start seeing it terminate and trim back a little bit, OK, based on that. So there it goes. It's killing 2 of the pods now. It basically is determined I only need 1 to basically handle the load you see going through it right now. Notice also, right here, if you see the pattern has changed, see it went from having different servers it's interacting with to all the same server. So it did that automatically. OK? So we are out of time. But let's kind of rock through this a little bit here, and then we'll do our giveaway, if you guys have done the Chromebook thing. So KNative was announced this past year by the Google team. Again, the concept of KNative is it basically sits on top of Kubernetes and gives you this kind of serverless-like capability, scale up from 0 and back down to 0. It also has 2 additional capabilities, one called build and one called eventing. So you can more easily build an image and push it through a build pipeline into a production environment. And the concept of going from source to a URL more quickly. And the eventing one is meant to be extended so that it has more than just HTTP input. What I showed you here is only HTTP. What about AMQP? What about MQTT? What about FTP? And that's what they're working on now. And that's still very new, as an example. OK, again, KNative is basically sitting on top of Istio and taking advantage of Istio capabilities right now. Building, serving, and eventing, that's the core of it. There's the GitHub URL for if you want to go check it out. The things, what I was just showing you, by the way, is actually documented as we try to document everything in this thing called the KNative tutorial. OK? And then there's a different set of blogs that Kamesh on my team just produced. And so you should go check those out if you're interested in KNative. And you want to see how the serving, the building, and all those things work, and along with the little demo I just showed you. One other thing to watch out for in this space is this thing called Cloud Events. So Cloud Events is trying to unify all the inputs and outputs for event-driven systems for all the different cloud providers. All right, so just keep that in mind. Again, the free books, as I mentioned yesterday. And that is all we have time for. But let's see if we can pick our winner. I have it limited to 1. That's me, by the way. So I'm not going to win the prize. But this is one I published just to see if it would work. OK? So let's hit refresh here. And this is our winner today. Let's see here. Stig. Stig, you here? Fantastic. So you're our winner today. But I'll be available for questions. And I know that we are basically out of time, right? So thank you so much.